Alright everybody, well we are here at the next video. Um, we're going to be talking about graphing lines at this point and how to graph them, since we just covered graphing in general, how to graph points and things like that. I do apologize, I feel a little sick right now, so you probably noticed that in my voice. Bear with me, do my best here. So, we're going to start with a little bit of vocab that we need to know for today's lesson. And we're going to look at it in the example of sledding. So, let's say that you are going sledding. So, here's our first situation. We have a nice field. You can see it has snow on it, which is pretty important for sledding, I would say. But you look at this place, and you'll notice that it's pretty flat. How fun would that be? How fun would it be to sled on flat ground? Probably not very fun. I mean, you might have a friend who's dragging you around, but, you know, there are better ways to sled than that, like hills are usually pretty nice. So, we wouldn't have very much fun on this hill. You might say that we would have zero fun on this hill, perhaps. So that's an important thing to keep in mind. Second example. Here we are, we're sledding again. There you are on your sled. And look at where we're sledding off of. So what we're doing here is we are sledding, and we go right over this hill, and we pretty much go straight down. Now, how much fun would that be? Maybe fun for you thrill seekers, but for those of you who like to keep your bones not broken, this might be a little bit of a scary prospect here. And for those of you who are excited about it, it might be too much fun. I don't know. Going over the side of a hill is kind of scary to me, but that is another case that we have. So we've looked at the flat surface, we've looked at the sheer side of a cliff going over it. What about this one? So we're sledding. This one looks to be, so we go down like that. Looks like there's a landing zone right there. This one looks pretty good, especially when you compare it to the other two. Of the three, this is probably the one that's most good to sled on. And the reason for that is its steepness is the perfect amount compared to the other two. So, this idea here is the idea of slope. And slope is basically how steep a hill is, or how steep a line is when we're talking about math. So, steepness is the same idea as slope. And that is a vocab word, so I would put that in your vocab. Slope is steepness. And we'll be coming back to other definitions of slope later as well. This was before your note sheet, so let's move to the note sheet then. And we're going to be talking about, again, how to graph here. Okay, so to graph a line in an equation using a table, there are three things that we're going to need to do, and they all start with P. First thing we're going to need to do is pick numbers for x. So oftentimes, -2, -1, 0, 1, and 2 are going to be good, but when you have a fraction in the problem, you'll want to make sure that you pick multiples of the fraction, of the denominator. So if you had a 1/3 in the problem, you would want to pick numbers like 3, 6, and 9, and -3 and -6. Numbers that are multiples of the denominator of the fraction. Next thing we'll do is we will plug in the number for x and evaluate to find y. And lastly, we will plot the points. Notice that this table has x's and y's, so we're going to be making ordered pairs. And lastly, we'll connect the dots. So let's see how this works. First example, we have y equals 5 minus 3x. Notice there is no fraction in this one, so we're just going to go with the standard -2, -1, 0, 1, and 2 for x. And we're going to plug those values in for x in this equation. So, for the first part, when we plug -2 in, we're going to have 5 minus, and then we have 3 times -2, which is -6. 5 minus negative 6 is the same thing as 5 plus 6, and 5 plus 6 is 11, and that's what I put in for y. Negative 1. We have 5 minus negative 1 times 3 is negative 3, so negative 3. 5 minus negative 3 is 5 plus 3, which is 8. 0. We have 5 minus 3 times 0, which is 0. 5 minus 0 is just 5. For 1, we have 5 minus 3 times 1, which is 3. 5 minus 3 is 2. And for 2, we have 5 minus 3 times 2, which is 6. 5 minus 6 is negative 1. Now, if you look here, we basically have a bunch of ordered pairs. If I put a parentheses here and a comma there, you see that we have the point negative 2, 11. So that's one of my points. So, on my graph, I'm going to start at the origin, and I'm going to go 2 spaces to the left, and then 11 spaces up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have to draw it actually a little bit above there. This is the point, negative 2, 11. And I'm just labeling it for you. You don't have to label it yourself. The next point we would have is negative 1, 8. So negative 1 tells me 1 to the left, and then 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Next point is 0, 5, so I don't move left or right, but I go up 5. 1, 2, 1 right, 2 up, and then 2 right, 1 down. So there are my points, and now my last step is I have to connect the dots. Put arrows at the end. The arrows tell the person looking at this that this line keeps going on forever, because it does. It never stops. We found 5 points, but we could find more if we really needed to. Next example. Okay, so here we have 2/3 x plus 1, y equals 2/3 x plus 1. Here's the denominator, it's 3. Remember that when you have a fraction, you want to choose multiples of that denominator. So I'm going to choose things like negative 6, negative 3, 0, 3, and 6. Why those numbers? Because 6 and 3, you can multiply easily to get, multiply by 3 to get those numbers. 1 times 3 is 3, 2 times 3 is 6. Okay, so you'll want to use your calculator for this. Make sure that you're plugging in 2/3 using the fraction features on your calculator, and it'll help you out. For our first one, when we plug negative 6 in, 2/3 times negative 6 is negative 4 plus 1. Negative 4 plus 1 is negative 3. Second one, negative 3. 2/3 times negative 3 is negative 2, and negative 2 plus 1 is negative 1. 2/3 times 0 is 0, plus that 1 gives us 1. 3 times 2/3 is 2, plus 1 gives us 3. And 6 times 2/3 is 4, and 4 plus 1 is 5. Now we plot these. So I start by going for this first point here. Remember, these are our points. So we have 6 to the left and 6 down. 1, 2, 3, 4, 5, 6, and then 1, 2, 3. So right there at that corner. Then we have negative 3, 1. 1, 2, 3 to the left, down 1. Then 0, 1, not left or right at all, but up 1. Then 3, 3, 3 to the right, 3 up. And then 6, 5. 6 to the right, and then 5 up. And then we connect the points. And there they are. Arrows at the end to indicate that it goes on forever. We have special lines, 2 of them. We have horizontal, which are lines that go left to right, and vertical, which are lines that go straight up and down. So we have these 2 types of lines, and we have an abbreviation that will help us remember which is which, and that is Hoivux, as you see here, Hoivux. So in this, we have a few things here. The H stands for horizontally. When you have a horizontal line, the slope of that line is 0. It's kind of like that flat sledding surface that we looked at earlier today. And the equation for that is going to be y equals a number. And we'll figure out how to get that number soon. So y equals 3 or y equals 5, something like that. So that's hoi. Then we have vux. Vux, V stands for vertical. The U stands for the slope, which is undefined. We can't really say there's a slope because it's too steep. And those ones are always going to look like x equals some number. So x equals 5 or x equals -5, things like that. All right. So here's the thing. If we were being asked to graph x equals -2, what that's telling us is that our x value needs to be -2. So right now, there's only one thing that I can put in for x, which is -2. It's telling us that. So the question is, what's y then? Is there really a pattern to it? And the answer is no. We can really put anything in for y. We can put in 37. We can put in 2. We can put in 0. We can put in -5. We can put in 7. We can put in anything, as long as our x value is -2. So what ends up happening is, if our x value is -2, we have to go 2 to the left, and then we plot our y points. Well, I can't plot 37. I shouldn't have chosen that one, I guess. But I can plot 2, and I can plot -2, 0, and I can plot -2, -5, and I can plot -2, 7. And notice that all these points are along a vertical line. That's that whole Vux idea. Vertical lines have an undefined slope and have the equation x equals something. Here, we have the other situation. We have y, we know it has to be 7, so I can say certainly that these are all going to be 7, and we can choose anything for x, like -8, or -5, or 0, or 2, or 7. So, what that means is, we find our x value, like the first one was -8, but we know that we're going to be going up 7. And then for the second point, if I go to the left 5, I know I'm going to be going up 7. And I know I'm going to be going up 7 at 0, and at 2, and at the other 7 I chose. So you see we have a horizontal line forming here. And that's that hoi part. So there's that. Now let's say we have to give the equations of these. Here's this first solid line right here. If you look at what's going on there, there's the origin. We are 1, 2, 3, 4, 5, 6 spaces away. That's a value of x equals 6, and it's a vertical line. So vertical lines have an undefined slope and an equation of x equals something. So that's going to be x equals 6 because it's 6 spaces over, and we know the slope is undefined. For the dashed line, which is this one right here, we can see that it's a horizontal line. So we're going to be using hoi here as opposed to vux, which means it's going to have an equation of y equals something. What is y at that line? We have go down 1, 2, 3, 4, 5 spaces. So it's going to be y equals -5, and we know the slope is 0. And lastly, the dotted line, right here. We see it's a vertical line, so we're going to use vux here, since it is a vertical line. We see that it's a vertical line, which means it's going to be x equals something, and the x value at that point is 0. So that's line x equals 0, and we know the slope is undefined. All right, so that is the note sheet. Make sure that you are starting to get working on the homework then, which you should be able to get from your teacher. Thanks, and good luck.